of Newton-Raphson method for two variables. Newton-Raphson method for two variables. Okay. So up till now we have studied the Newton-Raphson and modified Newton-Raphson, but these methods were operating only on a single variable. So our polynomial or the transcendental equation was containing only x term. Now suppose we have two terms f of x and y. So we need to have two equations to get the solution. Okay. So we can get the root of nonlinear equations having two variables, say x and y. So we can solve it with the help of Newton-Raphson method for two variable. So we have to consider the nonlinear equations having two variables x and y in such a way that, let us say f of x y equal to 0 is our first equation and g of x y is equal to 0 is our second equation. Okay. Now we'll expand this. We are studying the derivation. So we will expand these two equations with the help of Taylor series as we have expressed with the help of first one variable. Similarly, we will expand this with the two variables. So with two variables, what do we have? F of x of n plus 1, y of n plus 1. Similarly, g of x n plus 1, y of n plus 1. Both the equations are same. Only here f is written and here g is written because we are representing a function. Okay. Both are in the form of x and y variables. Okay. So f of x and y plus x of n plus 1 minus xn into derivative of f with respect to x. Okay. Plus now you can see this term and this term are same, only the difference is here x of n plus 1, here it is y of n plus 1. It is derivative of f with respect to x, here it is derivative of f with respect to y. Otherwise this term and this term both are same. Okay, so we are differentiating f with respect to x once and with respect to y once. Okay, that's it. Similarly, g of xn plus 1, y of xn plus 1. So as per Taylor series, it will be g of xn yn, okay, plus xn plus 1 minus xn dg upon dx xn yn plus y of n plus 1 minus yn dg upon dy. So this is derivative with respect to y dg upon dy xn yn. Okay. So this is Taylor series expansion and we have considered up to two terms only. This is the first term, this is the second term. Only we are considering these two terms. Okay. Because further terms are negligible, we can neglect it. Now I am writing the same equations, only I am equating it to the 0. Okay. So this was our first equation, 0 equal to f of x and y plus this is x term, this is xn term, this is y term. Only I am writing x terms together, y terms together. Okay. Now same is the case for g of xn. Okay. This is the second term. Now see what I am doing. So these two terms x n plus 1 and y n plus 1 I am taking to the other side. Okay. So see here x n plus 1 df upon dx x n y n. This term I am writing here as it is. Okay. Plus, so these two positive terms I am writing as it is equal to remaining terms I am shifting to the left hand side. So this f of x and y n will become minus f of x and y n. Okay. This is a minus term. So it will go as a plus term at the left hand side. So it is plus x n df upon dx x and y n. Similarly, this is minus y n df upon dy x and y n. So this will also become positive. So this is positive. Okay. Similarly, we'll do for g. So for g also I am taking x terms, these two positive terms as it is here. Okay, this is negative, so it will go to the left hand side. This g will be minus, g will be minus. This minus xn dg upon dx I'll take to the left hand side and minus yn dg upon dy that will also be shifted to left hand side. So we have these two equations. Okay. Now if we try to solve it, okay, we can have the solution as x of n plus 1, x of n plus 1, x of n plus 1. So n plus 1, y n plus 1, x n plus 1, y n plus 1. So it is similar to two equations with two variables and we can solve it. Okay. With the matrix solution, we can have, see, these are the two equations we'll solve with the help of matrix. So it is f of x and y n, g of x and y n. Okay, we are solving it for f of x and y n, g of x and y n. And the terms are df upon dy, df upon dy x and y n, dg upon dy x and y n. Okay, df upon dy x and y n, dg upon dy xn yn. Okay, so these two terms for xn plus 1, xyn plus 1. Okay, so this is f of xn yn, g of xn yn. This is df upon dy, this is dg upon dy, df upon dy, dg upon dy. Okay, divided by, this is xn minus, divided by Jacobi of f and g. What is Jacobi of f and g, that we will study. Before that, this is the x term. Similarly, y term is also similar, only here derivative is with respect to y for calculating x. Here derivative is with respect to x for calculating y. So you can observe here xn plus 1, here it is yn plus 1. Xn becomes yn. Only sign here is minus, here is plus. It is because of these equations. This is f of xn yn, g of xn yn. This is df upon dy, this is df upon dx with respect to x. dg upon dy, here it is dg upon dx because we are finding out the y. Okay, upon Jacobi of f and g. And what is Jacobi? Jacobi is df upon dx, df upon dy, dg upon dx, dg upon dy. That is the Jacobi. So we'll find out this matrix, we'll find out this matrix, we'll find out this matrix. If we substitute the values, we can get xn plus 1, yn plus 1 as the next roots. Okay, so here we have completed derivation. We will solve numerical in our next session of YouTube. Thank you.